Welcome to the crafting circle. As always, you guys can let me know what you are working on today, and we'll be continuing on listening to From the Earth to the Moon by Jules Verne. That was the audiobook we started last time, and we'll be picking up at chapter 6 and continuing on from there. We'll probably listen for about an hour. I am still working on this little postcard from the Secret Garden. And I think I should finish it up pretty soon. I'll show you. I'm trying to get through all of these before the end of the year. So I did 2 others. This one I mostly did while I was waiting for the cable person to come like a week ago. And then this one I was doing last night while I was watching the Packers game. And I really like the way this one is turning out, so I wanted to kind of show it to you. It's just a flower and it's pretty simple and going pretty quick. So I am going to be continuing on with this one. So welcome to all those of you who are joining me, and I think we should just get started and continue listening to From the Earth to the Moon. And I will talk to you guys in about 8 minutes when the chapter is over.
All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Alex Patterson. From the Earth to the Moon by Jules Verne. Chapter 6. Permissive Limits of Ignorance and Belief in the United States. The immediate result of Barbicane's proposition was to place upon the orders of the day all the astronomical facts relative to the Queen of the Night. Everybody set to work to study assiduously. One would have thought that the moon had just appeared for the first time, and that no one had ever before caught a glimpse of her in the heavens. The papers received all the old anecdotes in which the son of wolves played a part. They recalled the influences which the ignorance of past ages ascribed to her. In short, all America was seized with selenomania, or had become mood-mad. The scientific journals, for their part, dealt more especially with the questions which touched upon the enterprise of the Gun Club. The letter of the Observatory of Cambridge was published by them, and commented on with unreserved approval. Until that time, most people had been ignorant of the mode in which the distance which separates the earth from the moon is calculated. They took advantage of this fact to explain to them that this distance was obtained by measuring the parallax of the moon. The term parallax proving caviar to the general, they further explained that it meant the angle formed by the inclination of 2 straight lines drawn from either extremity of the earth's radius to the moon. On doubts being expressed as to the correctness of this method, they immediately proved that not only was the mean distance 234,347 miles, but that astronomers could not possibly be in error in their estimates by more than 70 miles either way. To those who were not familiar with the motions of the moon, they demonstrated that she possesses 2 distinct motions, the first being that of rotation upon her axis, the second being that of revolution round the earth, accomplishing both together in an equal period of time, that is to say, in 27 1/3 days. The motion of rotation is that which produces day and night on the surface of the moon. Save that there is only 1 day and 1 night in the lunar month, each lasting 354 1/3 hours, but, happily for her, the face turned toward the terrestrial globe is illuminated by it with an intensity equal to that of 14 moons. As to the other face, always invisible to us, it has of necessity 354 hours of absolute night, tempered only by that pale glimmer which falls upon it from the stars. Some well-intentioned but rather obstinate persons could not at first comprehend how, if the moon displays invariably the same face to the earth during her revolution, she can describe 1 turn round herself. To such they answered, "Go into your dining room and walk round the table in such a way as to always keep your face turned toward the center. By the time you will have achieved 1 complete round, you will have completed 1 turn around yourself, since your eye will have traversed successively every point of the room. Well then, the room is the heavens, the table is the earth, and the moon is yourself." And they would go away delighted. So then, the moon displays invariably the same face to the earth. Nevertheless, to be quite exact, it is necessary to add that, in consequence of certain fluctuations of north and south, and of west and east, termed her libration, she permits rather more than half, that is to say, 5/7, to be seen. As soon as the ignoramuses came to understand as much as the director of the observatory himself knew, they began to worry themselves regarding her revolution round the earth, whereupon 20 scientific reviews immediately came to the rescue. They pointed out to them that the firmament, with its infinitude of stars, may be considered as one vast dial plate, upon which the moon travels, indicating the true time to all the inhabitants of the earth, that it is during this movement that the Queen of Night exhibits her different phases, that the moon is full when she is in opposition with the sun, that is, when the three bodies are on the same straight line, the earth occupying the center, that she is new when she is in conjunction with the sun, that is, when she is between it and the earth, and lastly, that she is in her first or last quarter when she makes with the sun and the earth an angle of which she herself occupies the apex. Regarding the altitude which the moon attains above the horizon, the letter of the Cambridge University had said all that was to be said in this respect. Everyone knew that this altitude varies according to the latitude of the observer, but the only zones of the globe in which the moon passes the zenith, that is, the point directly over the head of the spectator, are of necessity comprised between the 28th parallels and the equator. Hence the importance of the advice to try the experiment upon some point of that part of the globe, in order that the projectile might be discharged perpendicularly, and so the soonest escape the action of gravitation. This was an essential condition to the success of the enterprise, and continued actively to engage the public attention. Regarding the path described by the moon in her revolution round the earth, the Cambridge Observatory had demonstrated that this path is a re-entering curve, not a perfect circle, but an ellipse, of which the earth occupies one of the foci. It was also well understood that it is furthest removed from the earth during its apogee, and approaches most nearly to it at its perigee. Such was the extent of knowledge possessed by every American on the subject, and of which no one could decently profess ignorance. Still, while these principles were being rapidly disseminated, many errors and illusory fears proved less easy to eradicate. For instance, some worthy persons maintained that the moon was an ancient comet, which, in describing its elongated orbit round the sun, happened to pass near the earth, and became confined within her circle of attraction. These drawing-room astronomers professed to explain the charred aspect of the moon, a disaster which they attributed to the intensity of the solar heat, only, on being reminded that comets have an atmosphere and that the moon has little or none, they were fairly at a loss for a reply. Others again, belonging to the doubting class, expressed certain fears as to the position of the moon. They had heard it said that, according to observations made in the time of the caliphs, her revolution had become accelerated in a certain degree. Hence they concluded, logically enough, that an acceleration of motion ought to be accompanied by a corresponding diminution in the distance separating the two bodies, and that, supposing the double effect to be continued to infinity, the moon would end by one day falling into the earth. However, they became reassured as to the fate of future generations on being apprised that, according to the calculations of Laplace, this acceleration of motion is confined within very restricted limits, and that a proportional diminution of speed would be certain to succeed it. So then, the stability of the solar system would not be deranged in ages to come. There remains but the third class, the superstitious. These worthies were not content merely to rest in ignorance. They must know all about things which had no existence whatsoever, and as to the moon, they had long known all about her. One set regarded her disk as a polished mirror, by means of which people could see each other from different points of the earth and interchange their thoughts. Another set pretended that out of 1,000 new moons that had been observed, 950 had been attended with remarkable disturbances, such as cataclysms, revolutions, earthquakes, the deluge, etc. Then they believed in some mysterious influence exercised by her over human destinies, that every Selenite was attached to some inhabitant of the earth by a tie of sympathy. They maintained that the entire vital system is subject to her control, etc. But in time the majority renounced these vulgar errors, and espoused the true side of the question. As for the Yankees, they had no other ambition than to take possession of this new continent of the sky, and to plant upon the summit of its highest elevation the star-spangled banner of the United States of America. End of chapter 6.
Sorry, it took me a minute there to pause things. Yes. So now we've learned more about the moon. I'm just going to continue on to the next chapter because I don't know how much there is to comment about that. Hey, Tatiana. Good to see you. Yeah, now we know more about the moon. So let's continue on to chapter 7.
This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This reading by Alex Patterson. From the Earth to the Moon by Jules Verne. Chapter 7, The Hymn of the Cannonball. The Observatory of Cambridge, in its memorable letter, had treated the question from a purely astronomical point of view. The mechanical part still remained. President Barbicane had, without loss of time, nominated a working committee of the Gun Club. The duty of this committee was to resolve the three grand questions of the cannon, the projectile, and the powder. It was composed of 4 members of great technical knowledge: Barbicane, with a casting vote in case of equality, General Morgan, Major Elphinstone, and J.T. Maston, to whom were confided the functions of secretary. On the 8th of October, the committee met at the house of President Barbicane, 3 Republican Street. The meeting was opened by the president himself. "Gentlemen," he said, "we have to resolve one of the most important problems in the whole of the noble science of gunnery. It might appear, perhaps, the most logical course to devote our first meeting to the discussion of the engine to be employed. Nevertheless, after mature consideration, it has appeared to me that the question of the projectile must take precedence of that of the cannon, and that the dimensions of the latter must necessarily depend on those of the former." "Suffer me to say a word," here broke in J.T. Maston. Permission having been granted, "Gentlemen," said he with an inspired accent, "our president is right in placing the question of the projectile above all others. The ball we are about to discharge at the moon is our ambassador to her, and I wish to consider it from a moral point of view. The cannonball, gentlemen, to my mind, is the most magnificent manifestation of human power. If Providence has created the stars and the planets, man has called the cannonball into existence. Let Providence claim the swiftness of electricity and of light, of the stars, the comets, and the planets, of wind and sound. We claim to have invented the swiftness of the cannonball, 100 times superior to that of the swiftest horses or railway train. How glorious will be the moment when, infinitely exceeding all hitherto attained velocities, we shall launch our new projectile with the rapidity of 7 miles a second! Shall it not, gentlemen, shall it not be received up there with the honors due to a terrestrial ambassador?" Overcome with emotion, the orator sat down and applied himself to a huge plate of sandwiches before him. "And now," said Barbicane, "let us quit the domain of poetry and come direct to the question." "By all means," replied the members, each with his mouthful of sandwich. "The problem before us," continued the president, "is how to communicate to a projectile a velocity of 12,000 yards per second. Let us at present examine the velocities hitherto attained. General Morgan will be able to enlighten us on this point." "And the more easily," replied the general, "that during the war I was a member of the Committee of Experiments. I may say, then, that the 100-pounder Dahlgrens, which carried a distance of 5,000 yards, impressed upon the projectile an initial velocity of 500 yards a second. The Rodman Columbiad threw a shot weighing half a ton, a distance of 6 miles, with a velocity of 800 yards per second, a result which Armstrong and Palliser have never obtained in England." "This," replied Barbicane, "is, I believe, the maximum velocity ever attained." "It is so," replied the general. "Ah," groaned J.T. Maston, "if my mortar had not burst!" "Yes," quietly replied Barbicane, "but it did burst. We must take, then, for our starting point, this velocity of 800 yards. We must increase it 20-fold. Now, reserving for another discussion the means of producing this velocity, I will call your attention to the dimensions which it will be proper to assign to the shot. You understand that we have nothing to do here with projectiles weighing at most but half a ton." "Why not?" demanded the major. "Because the shot," quickly replied J.T. Maston, "must be big enough to attract the attention of the inhabitants of the moon, if there are any." "Yes," replied Barbicane, "and for another reason more important still." "What mean you?" asked the major. "I mean that it is not enough to discharge a projectile and then to take no further notice of it. We must follow it throughout its course, up to the moment when it shall reach its goal." "What!" shouted the general and the major in great surprise. "Undoubtedly," replied Barbicane composedly, "or our experiment would produce no result." "But then," replied the Major, "you will have to give this projectile enormous dimensions." "No! Be good as to listen. You know that optical instruments have acquired great perfection. With certain instruments we have succeeded in obtaining enlargements of 6,000 times and reducing the moon to within 40 miles distance. Now, at this distance, any objects 60 feet square would be perfectly visible. If, then, the penetrative power of telescopes has not been further increased, it is because that power detracts from their light, and the moon, which is but a reflecting mirror, does not give back sufficient light to enable us to perceive objects of lesser magnitude." "Well, then, what do you propose to do?" asked the general. "Would you give your projectile a diameter of 60 feet?" "Not so." "Do you intend, then, to increase the luminous power of the moon?" "Exactly so. If I can succeed in diminishing the density of the atmosphere through which the moonlight has to travel, I shall have rendered her light more intense. To effect that object it will be enough to establish a telescope on some elevated mountain. That is what we will do." "I give it up," answered the Major. "You have such a way of simplifying things, and what enlargement do you expect to obtain in this way?" "One of 48,000 times, which should bring the moon within an apparent distance of 5 miles, and, in order to be visible, objects need not have a diameter of more than 9 feet." "So, then," cried J.T. Maston, "our projectile need not be more than 9 feet in diameter." "Let me observe, however," interrupted Major Elphinstone, "this will involve a weight such as—" "My dear Major," replied Barbicane, "before discussing its weight, permit me to enumerate some of the marvels which our ancestors have achieved in this respect. I don't mean to pretend that the science of gunnery was not advanced, but it is well to bear in mind that during the Middle Ages they obtained results more surprising, I will venture to say, than ours. For instance, during the siege of Constantinople by Mahomet II, in 1453, stones shot of 1,900 pounds weight were employed. At Malta, in the time of the knights, there was a gun of the fortress of St. Elmo which threw a projectile weighing 2,500 pounds. And now, what is the extent of what we have seen ourselves? Armstrong guns discharging shot of 500 pounds, and the Rodman guns projectiles of half a ton. It seems, then, that if projectiles have gained in range, they have lost far more in weight. Now, if we turn our efforts in that direction, we ought to arrive, with the progress on science, at 10 times the weight of the shot of Mahomet II and the Knights of Malta." "Clearly," replied the Major, "but what metal do you calculate upon employing?" "Simply cast iron," said General Morgan. "But," interrupted the Major, "since the weight of the shot is proportionate to its volume, an iron ball of 9 feet in diameter would be of tremendous weight." "Yes, if it were solid." "Not if it were hollow." "Hollow? Then it would be a shell." "Yes, a shell," replied Barbicane. "Decidedly it must be. A solid shot of 108 inches would weigh more than 200,000 pounds, a weight evidently far too great. Still, as we must reserve a certain stability for our projectile, I propose to give it a weight of 20,000 pounds." "What, then, will be the thickness of the sides?" asked the Major. "If we follow the usual proportion," replied Morgan, "a diameter of 108 inches would require sides of 2 feet thickness, or less." "That would be too much," replied Barbicane, "for you will observe that the question is not that of a shot intended to pierce an iron plate. It will suffice to give its sides strong enough to resist the pressure of the gas. The problem, therefore, is this: what thickness ought a cast iron shell to have in order not to weigh more than 20,000 pounds? Our clever secretary will soon enlighten us upon this point." "Nothing easier," replied the worthy secretary of the committee, and, rapidly tracing a few algebraical formulae upon paper, among which n² and x² frequently appeared, he presently said, "The sides will require a thickness of less than 2 inches." "Will that be enough?" asked the Major doubtfully. "Clearly not," replied the president. "What is to be done, then?" said Elphinstone, with a puzzled air. "Employ another metal instead of iron." "Copper?" said Morgan. "No, that would be too heavy. I have better than that to offer." "What, then?" asked the Major. "Aluminum," replied Barbicane. "Aluminum!" cried his 3 colleagues in chorus. "Unquestionably, my friends, this valuable metal possesses the whiteness of silver, the indestructibility of gold, the tenacity of iron, the fusibility of copper, the lightness of glass. It is easily wrought, it is very widely distributed, forming the base of most of the rocks. It is 3 times lighter than iron, and seems to have been created for the express purpose of furnishing us with the material for our projectile. But, my dear President, said the Major, is not the cost of aluminum extremely high? It was so at its first discovery, but it has fallen now to $9 a pound. But still, $9 a pound, replied the Major, who was not willing readily to give in. Even that is an enormous price. Undoubtedly, my dear Major, but not beyond our reach. What will the projectile weigh, then? Asked Morgan. Here is the result of my calculations, replied Barbicane. A shot of 108 inches in diameter and 12 inches in thickness would weigh in cast iron 67,440 pounds. Cast in aluminum, its weight will be reduced to 19,250 pounds. Capital! Cried the Major. But do you know that, at $9 a pound, this projectile will cost $173,050. I know it quite well. But fear not, my friends, the money will not be wanting for our enterprise. I will answer for it. Now what say you to aluminum, gentlemen? Adopted, replied the 3 members of the committee. So ended the first meeting. The question of the projectile was definitely settled. End of chapter 7.
Alright, so that is the end of chapter 7, obviously. Interesting, Jules Verne putting the science in science fiction like 100 years before rocket science was actually a thing. So, I guess they're not going to shoot a person to the moon, they're going to shoot an aluminum ball at the moon. I thought it was going to be a person. I'm going to hold out hope that they will eventually try and shoot a person at the moon. But, might not happen. So let's continue on to the next chapter. And you guys can, as always, let me know what you are working on. And let us continue.
This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This reading by Alex Patterson. From the Earth to the Moon by Jules Verne. Chapter 8. History of the Cannon. The resolutions passed at the last meeting produced a great effect out of doors. Timid people took fright at the idea of a shot weighing 20,000 pounds being launched into space. They asked what cannon could ever transmit a sufficient velocity to such a mighty mass. The minutes of the second meeting were destined triumphantly to answer such questions. The following evening the discussion was renewed. My dear colleagues, said Barbicane, without further preamble, the subject now before us is the construction of the engine, its length, its composition, and its weight. It is probable that we shall end by giving it gigantic dimensions, but however great may be the difficulties in the way, our mechanical genius will readily surmount them. Be good enough, then, to give me your attention, and do not hesitate to make objections at the close. I have no fear of them. The problem before us is how to communicate an initial force of 12,000 yards per second to a shell of 108 inches in diameter, weighing 20,000 pounds. Now, when a projectile is launched into space, what happens to it? It is acted upon by 3 independent forces: the resistance of the air, the attraction of the earth, and the force of impulsion with which it is endowed. Let us examine these 3 forces. The resistance of the air is of little importance. The atmosphere of the earth does not exceed 40 miles. Now, with the given rapidity, the projectile will have traversed this in 5 seconds, and the period is too brief for the resistance of the medium to be regarded otherwise than as insignificant. Proceeding, then, to the attraction of the earth, that is, the weight of the shell, we know that this weight will diminish in the inverse ratio of the square of the distance. When a body left to itself falls to the surface of the earth, it falls 5 feet in the first second, and if the same body were removed 257,542 miles further off, in other words, to the distance of the moon, its fall would be reduced to about half a line in the first second. That is almost equivalent to a state of perfect rest. Our business, then, is to overcome progressively this action of gravitation. The mode of accomplishing this is by the force of impulsion. There is a difficulty, broke in the Major. True, replied the President, but we will overcome that, for the force of impulsion will depend upon the length of the engine and the powder employed, the latter being limited only to the resisting power of the former. Our business, then, today, is with the dimensions of the cannon. Now up to the present time, said Barbicane, our longest guns have not exceeded 25 feet in length. We shall therefore astonish the world by the dimensions we shall be obliged to adopt. It must evidently be, then, a gun of great range, since the length of the piece will increase the detention of the gas accumulated behind the projectile, but there is no advantage in passing certain limitations. Quite so, said the Major. What is the rule in such a case? Ordinarily, the length of a gun is 20 to 25 times the diameter of the shot, and its weight 235 to 240 that of the shot. That is not enough, cried J.T. Maston impetuously. I agree with you, my good friend, and, in fact, following this proportion for a projectile 9 feet in diameter, weighing 30,000 pounds, the gun would only have a length of 225 feet, and a weight of 7,200,000 pounds. Ridiculous, rejoined Maston. As well take a pistol. I think so too, replied Barbicane. That is why I propose to quadruple that length, and to construct a gun of 900 feet. The general and the major offered some objections. Nevertheless, the proposition, actively supported by the secretary, was definitely adopted. But, said Elphinstone, what thickness must we give it? A thickness of 6 feet, replied Barbicane. You surely don't think of mounting a mass like that upon a carriage? Asked the major. It would be a superb idea, though, said Maston. But impracticable, replied Barbicane. No, I think of sinking this engine into the earth alone, binding it with hoops of wrought iron, and finally surrounding it with a thick mass of masonry of stone and cement. The piece once cast, it must be bored with great precision, so as to preclude any possible windage, so there will be no loss whatever of gas, and all the expansive force of the powder will be employed in the propulsion. One simple question, said Elphinstone. Is our gun to be rifled? No, certainly not, replied Barbicane. We require an enormous initial velocity, and you are well aware that a shot quits a rifled gun less rapidly than it does a smooth-bore. True, rejoined the major. The committee here adjourned for a few minutes to tea and sandwiches. On the discussion being renewed, gentlemen, said Barbicane, we must now take into consideration the metal to be employed. Our cannon must be possessed of great tenacity, great hardness, be infusible by heat, indissoluble, and inoxidable by the corrosive action of acids. There is no doubt about that, replied the major, and as we shall have to employ an immense quantity of metal, we shall not be at a loss for choice. Well, then, said Morgan, I propose the best alloy hitherto known, which consists of 100 parts of copper, 12 of tin, and 6 of brass. I admit, replied the president, that this composition has yielded excellent results, but in the present case it would be too expensive and very difficult to work. I think, then, that we ought to adopt a material excellent in its way and low of price. Such as cast iron? What is your advice, Major? I quite agree with you, replied Elphinstone. In fact, continued Barbicane, cast iron costs 10 times less than bronze. It is easy to cast, it runs readily from the mold of sand, it is easy of manipulation, it is at once economical of money and of time. In addition, it is excellent as a material, and I will remember that during the war, at the siege of Atlanta, some iron guns fired 1,000 rounds at intervals of 20 minutes without injury. Cast iron is very brittle, though, replied Morgan. Yes, but it possesses great resistance. I will now ask our worthy secretary to calculate the weight of a cast iron gun with a bore of 9 feet and a thickness of 6 feet of metal. In a moment, replied Maston, then, dashing off some algebraical formulae with marvelous facility, in a minute or two he declared the following result. The cannon will weigh 68,040 tons, and, at 2 cents a pound, it will cost $2,510,701. Maston, the major, and the general regarded Barbicane with uneasy looks. Well, gentlemen, replied the president, I repeat that I said yesterday, make yourselves easy. The millions will not be wanting. With this assurance of their president, the committee separated, after having fixed their third meeting for the following evening. End of chapter 8.
Okay, so they're going to build, apparently, the world's most expensive cannon to fire things to the moon. I do really like how all of the scientific discussions, all of the little conferences, how sandwiches are very important, because this is very true. Scientific conferences, sandwiches are very important. And if there's free food, people will show up to that talk. It's true. So yes, so let us continue on with the next chapter And depending on the length of this, we'll probably get through at least 2 more.
This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This reading by Alex Patterson. From the Earth to the Moon by Jules Verne. Chapter 9. The Question of the Powders. There remained for consideration merely the question of powders. The public awaited with interest its final decision. The size of the projectile, the length of the cannon being settled, what would be the quantity of powder necessary to produce impulsion. It is generally asserted that gunpowder was invented in the 14th century by the monk Schwartz, who paid for his grand discovery with his life. It is, however, pretty well proved that this story ought to be ranked among the legends of the Middle Ages. Gunpowder was not invented by anyone. It was the lineal successor of the Greek fire, which, like itself, was composed of sulfur and saltpeter. Few persons are acquainted with the mechanical power of gunpowder. Now this is precisely what is necessary to be understood in order to comprehend the importance of the question submitted to the committee. A liter of gunpowder weighs about 2 pounds. During combustion, it produces 400 liters of gas. This gas, on being liberated and acted upon by temperature raised to 2,400 degrees, occupies a space of 4,000 liters. Consequently, the volume of powder is to the volume of gas produced by its combustion as 1 to 4,000. One may judge, therefore, of the tremendous pressure of this gas when compressed within a space 4,000 times too confined. All this was, of course, well known to the members of the committee when they met on the following evening. The first speaker on this occasion was Major Elphinstone, who had been the director of the gunpowder factories during the war. "Gentlemen," said the distinguished chemist, "I began with some figures which will serve as the basis of our calculation. The old 24-pounder shot required for its discharge 16 pounds of powder." "You are certain of this amount?" broke in Barbicane. "Quite certain," replied the major. "The Armstrong cannon employs only 75 pounds of powder for a projectile of 800 pounds, and the Rodman Columbiad uses only 160 pounds of powder to send its half-ton shot a distance of 6 miles. These facts cannot be called in question, for I myself raised the point during the depositions taken before the Committee of Artillery." "Quite true," said the general. "Well," replied the major, "these figures go to prove that the quantity of powder is not increased with the weight of the shot. That is to say, if a 24-pounder shot requires 16 pounds of powder, in other words, if in ordinary gun we employ a quantity of powder equal to 2/3 of the weight of the projectile, the proportion is not constant. Calculate, and you will see that in place of 333 pounds of powder, the quantity is reduced to no more than 160 pounds. "What are you aiming at?" asked the president. "If you push your theory to extremes, my dear major," said J.T. Maston, "you will get to this, that as soon as your shot becomes sufficiently heavy, you will not require any powder at all." "Our friend Maston is always at his jokes, even in serious matters," cried the major. "But let him make his mind easy. I am going presently to propose gunpowder enough to satisfy his artillerist's propensities. I only keep to statistical facts when I say that, during the war, and for the very largest guns, the weight of the powder was reduced, as the result of experience, to 1/10 part of the weight of the shot." "Perfectly correct," said Morgan, "but before deciding the quantity of powder necessary to give the impulse, I think it would be as well—" "We shall have to employ a large-grained powder," continued the major. "Its combustion is more rapid than that of a small." "No doubt about that," replied Morgan, "but it is very destructive, and ends by enlarging the bore of the pieces." "Granted, but that which is injurious to a gun destined to be performed long service is not so to our Columbiad. We shall run no danger of explosion, and it is necessary that our powder should take fire instantly in order that its mechanical effect may be complete." "We must have," said Maston, "several touch-holes, so as to fire it at different points at the same time." "Certainly," replied Elphinstone, "but that will render the working of the piece more difficult. I return, then, to my large-grained powder, which removes these difficulties. In his Columbiad charges, Rodman employed a powder as large as chestnuts, made of willow charcoal, simply dried in cast-iron pans. This powder was hard and glittering, but left no trace upon the hand, contained hydrogen and oxygen in large proportion, took fire instantaneously, and, though very destructive, did not sensibly injure the mouthpiece." Up to this point Barbicane had kept aloof from the discussion. He left the others to speak, while he himself listened. He had evidently got an idea. He now simply said, "Well, my friends, what quantity of powder do you propose?" The three members looked at one another. 200,000 pounds, at last said Morgan. 500,000, added the major. 800,000, screamed Maston. A moment of silence followed this triple proposal. It was at last broken by the president. "Gentlemen," he quietly said, "I start from this principle, that the resistance of a gun, constructed under the given conditions, is unlimited. I shall surprise our friend Maston, then, by stigmatizing his calculations as timid, and I propose to double his 800,000 pounds of powder." 1,600,000 pounds! shouted Maston, leaping from his seat. "Just so. We shall have to come, then, to my ideal of a cannon half a mile long, for you see, 1,600,000 pounds will occupy a space of about 20,000 cubic feet, and since the contents of your cannon do not exceed 54,000 cubic feet, it would be half full, and the bore will not be more than long enough for the gas to communicate to the projectile sufficient impulse. Nevertheless, said the president, I hold to that quantity of powder. Now, 1,600,000 pounds of powder will create 6,000 millions liters of gas. 6,000 millions! You quite understand? What is to be done, then? Said the general. The thing is very simple. We must reduce this enormous quantity of powder while preserving to it its mechanical power. Good, but by what means? I am going to tell you, replied Barbicane quietly. Nothing is more easy than to reduce this mass to 1/4 of its bulk. You know that curious cellular matter which constitutes the elementary tissue of vegetables? This substance is quite pure in many bodies, especially in cotton, which is nothing more than the down of the seeds of the cotton plant. Now cotton, combined with cold nitric acid, become transformed into a substance eminently soluble, combustible, and explosive. It was first discovered in 1832 by Branchon, a French chemist, who called it xyloidine. In 1838, another Frenchman, Pelouse, investigated its different properties, and finally, in 1846, Schobine, the professor of chemistry at Bâle, proposed its employment for purposes of war. This powder, now called pyroxyle, or fulminating cotton, is prepared with great facility by simply plunging cotton for 15 minutes in nitric acid, then washing it in water, then drying it, and it is ready for use. Nothing could be more simple, said Morgan. Moreover, pyroxyle is unaltered by moisture, a valuable property to us, inasmuch as it would take several days to charge the cannon. It ignites at 170 degrees in place of 240, and its combustion is so rapid that one may set light to it on the top of the ordinary powder without the latter having time to ignite. Perfect! exclaimed the major. Only it is more expensive. What matter? cried J.T. Maston. Finally, it imparts to the projectile a velocity 4 times superior to that of gunpowder. I will even add that if we mix it with 1/8 of its own weight of nitrate of potassium, its expansive force is again considerably augmented. Will that be necessary? asked the major. I think not, replied Barbicane. So then, in place of 1,600,000 pounds of powder, we shall have but 400,000 pounds of fulminating cotton, and since we can, without danger, compress 500 pounds of cotton into 27 cubic feet, the whole quantity will not occupy a height of more than 180 feet within the bore of the Columbiad. In this way, the shot will have more than 700 feet of bore to traverse under a force of 6 billion liters of gas before taking its flight toward the moon. At this juncture, J.T. Maston could not repress his emotion. He flung himself into the arms of his friend with the violence of a projectile, and Barbicane would have been stove in if he had not been bomb-proof. This incident terminated the third meeting of the committee. Barbicane and his bold colleagues, to whom nothing seemed impossible, had succeeded in solving the complex problems of projectile, cannon, and powder. Their plan was drawn up, and it only remained to put it into execution. A mere matter of detail, a bagatelle, said J.T. Maston. End of chapter 9.
All right. Let's see what happens when the cannon gets fired. Yes, that was very interesting. I think Jules Verne has pretty conclusively proved why putting someone in a cannon and shooting them at the moon would not work out, because they're building a ridiculously giant cannon. Like, ridiculously large cannon. Okay, let us continue on.
This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This reading by Alex Patterson. From the Earth to the Moon by Jules Verne. Chapter 10. One Enemy versus 25 Millions of Friends. The American public took a lively interest in the smallest details of the enterprise of the Gun Club. It followed day by day the discussion of the committee. The most simple preparations for the great experiment, the questions of figures which it involved, the mechanical difficulties to be resolved, in one word, the entire plan of work, roused the popular excitement to the highest pitch. The purely scientific attraction was suddenly intensified by the following incident. We have seen what legions of admirers and friends Barbicane's project had rallied round its author. There was, however, one single individual alone in all the states of the Union who protested against the attempt of the Gun Club. He attacked it furiously on every opportunity, and human nature is such that Barbicane felt more keenly the opposition of that one man than he did the applause of all the others. He was well aware of the motive of this antipathy, the origin of this solitary enmity, the cause of its personality and old standing, and in what rivalry of self-love it had its rise. This persevering enemy the president of the Gun Club had never seen. Fortunate that it was so, for a meeting between the two men would certainly have been attended with serious consequences. This rival was a man of science, like Barbicane himself, of a fiery, daring, and violent disposition, a pure Yankee. His name was Captain Nicholl. He lived in Philadelphia. Most people are aware of the curious struggle which arose during the Federal War between the guns and armor of iron-plated ships. The result was the entire reconstruction of the navy of both the continents. As the one grew heavier, the other became thicker in proportion. The Merrimac, the Monitor, the Tennessee, and the Weehawken discharged enormous projectiles themselves, after having been armor-clad against the projectiles of the other. In fact, they did to others that which they would not they should do to them, that grand principle of immortality upon which rests the whole art of war. Now if Barbicane was a great founder of shot, Nicholl was a great forger of plates, the one cast night and day at Baltimore, the other forged day and night in Philadelphia. As soon as ever Barbicane invented a new shot, Nicholl invented a new plate. Each followed a current of ideas essentially opposed to the other. Happily for these citizens, so useful to their country, a distance of from 50 to 60 miles separated them from one another, and they had never yet met. Which of these inventors had the advantage over the other, it was difficult to decide from the results obtained. By last accounts, however, it would seem that the armor plate would in the end have to give way to the shot. Nevertheless, there were competent judges who had their doubts on the point. At the last experiment, the cylindrico-conical projectiles of Barbicane struck like so many pins in the Nicholl plates. On that day the Philadelphia iron forger then believed himself victorious, and could not evince contempt enough for his rival. But when the other afterward substituted for conical shot simple 600-pound shells at very moderate velocity, the captain was obliged to give in. In fact, these projectiles knocked his best metal plate to shivers. Matters were at this stage, and victory seemed to rest with the shot, when the war came to an end on the very day when Nicholl had completed a new armor plate of wrought steel. It was a masterpiece of its kind, and bid defiance to all the projectiles of the world. The captain had it conveyed to the Polygon at Washington, challenging the president of the Gun Club to break it. Barbicane, peace having been declared, declined to try the experiment. Nicholl, now furious, offered to expose his plate to the shock of any shot, solid, hollow, round, or conical, refused by the president, who did not choose to compromise his latest success. Nicholl, disgusted by this obstinacy, tried to tempt Barbicane by offering him every chance. He proposed to fix the plate within 200 yards of the gun. Barbicane still obstinate in refusal. 100 yards? Not even 75? At 50 then, roared the captain through the newspapers. At 25 yards, and I'll stand behind. Barbicane returned for answer that, even if Captain Nicholl would be so good as to stand in front, he would not fire any more. Nicholl could not contain himself at this reply, threw out hints of cowardice, that a man who refused to fire a cannon shot was pretty near being afraid of it, that artillerists who fight at 6 miles distance are substituting mathematical formulae for individual courage. To these insinuations Barbicane returned no answer, Perhaps he never heard of them, so absorbed was he in the calculations for his great enterprise. When his famous communication was made to the Gun Club, the captain's wrath passed all bounds. With his intense jealousy was mingled a feeling of absolute impotence. How was he to invent anything to beat this 900 feet Columbiad? What armor plate could ever resist a projectile of 30,000 pounds weight? Overwhelmed at first under this violent shock, he by and by recovered himself, and resolved to crush the proposal by weight of his arguments. He then violently attacked the laborers of the Gun Club, published a number of letters in the newspapers, endeavored to prove Barbicane ignorant of the first principles of gunnery. He maintained that it was absolutely impossible to impress upon any body whatever a velocity of 12,000 yards per second, that, even with such a velocity, a projectile of such weight could not transcend the limits of the earth's atmosphere. Further still, even regarding the velocity to be acquired, and, granting it to be sufficient, the shell could not resist the pressure of the gas developed by the ignition of 1,600,000 pounds of powder, and, supposing it to resist that pressure, it would be less able to support that temperature. It would melt on quitting the Columbiad, and fall back in a red-hot shower upon the heads of the imprudent spectators. Barbicane continued his work without regarding these attacks. Nicholl, then, took up the question in its other aspects. Without touching upon its uselessness in all points of view, he regarded the experiment as fraught with extreme danger, both to the citizens who might sanction by their presence so reprehensible a spectacle, and also to the towns in the neighborhood of this deplorable cannon. He also observed that if the projectile did not succeed in reaching its destination, a result absolutely impossible, it must inevitably fall back upon the earth, and that the shock of such a mass, multiplied by the square of its velocity, would seriously endanger every point of the globe. Under the circumstances, therefore, and without interfering with the rights of free citizens, it was a case for the intervention of the government, which ought not to endanger the safety of all for the pleasure of one individual. In spite of all his arguments, however, Captain Nicholl remained alone in his opinion. Nobody listened to him, and he did not succeed in alienating a single admirer from the president of the Gun Club. The latter did not even take the pains to refute the arguments of his rival. Nicholl, driven into his last entrenchments, and not able to fight personally in the cause, resolved to fight with money. He published, therefore, in the Richmond Enquirer, a series of wagers, conceived in these terms, and on an increasing scale. Number 1, $1,000. That the necessary funds for the experiment of the Gun Club will not be forthcoming. Number 2, $2,000. That the operation of casting such a cannon of 900 feet is impracticable, and cannot possibly succeed. Number 3, $3,000. That it is impossible to load the Columbiad, and that the pyroxyle will take fire spontaneously under the pressure of the projectile. Number 4, $4,000. That the Columbiad will burst at the first fire. Number 5, $5,000. That the shot will not travel farther than 6 miles, and that it will fall back again a few seconds after its discharge. It was an important sum, therefore, which the captain risked in his invincible obstinacy. He had no less than $15,000 at stake. Notwithstanding the importance of the challenge, on the 19th of May he received a sealed packet containing the following superbly laconic reply: Baltimore, October 19. Done. Barbicane. End of chapter 10.
Alright, so that is chapter 10. And I really want to see them try and shoot the cannon, so I'm just going to continue on to the next chapter, where hopefully that will happen. Where is it? Here it is. And it looks like we'll probably just do one more chapter tonight, and then that'll be it for the day. So one more chapter for the night.
Chapter 11, From the Earth to the Moon.
Different narrator.
This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. From the Earth to the Moon by Jules Verne. Chapter 11, Florida and Texas. One question remained to be decided. It was necessary to choose a favorable spot for the experiment. According to the advice of the Observatory of Cambridge, the gun must be fired perpendicularly to the plane of the horizon, that is to say, toward the zenith. Now the moon does not traverse the zenith except in places situated between 0 and 28 degrees of the latitude. It became, then, necessary to determine exactly that spot on the globe where the immense Columbiad should be cast. On the 20th of October, at a general meeting of the Gun Club, Barbicane produced a magnificent map of the United States. "Gentlemen," said he, in opening the discussion, "I presume that we are all agreed that this experiment cannot and ought not to be tried anywhere but within the limits of the soil of the Union. Now, by good fortune, certain frontiers of the United States extend downward as far as the 28th parallel of the north latitude. If you will cast your eye over this map, you will see that we have at our disposal the whole of the southern portion of Texas and Florida." It was finally agreed, then, that the Columbiad must be cast on the soil of either Texas or Florida. The result, however, of this decision was to create a rivalry entirely without precedent between the different towns of these two states. The 28th parallel, on reaching the American coast, traverses the peninsula of Florida, dividing it into two nearly equal portions. Then, plunging into the Gulf of Mexico, it subtends the arc formed by Alabama, Mississippi, and Louisiana. Then, skirting Texas, off which it cuts an angle, it continues its course over Mexico, crosses the Sonora, Old California, and loses itself in the Pacific Ocean. It was, therefore, only those portions of Texas and Florida which were situated below this parallel which came within the prescribed conditions of latitude. Florida, in its southern part, reckons no cities of importance. It is simply studded with forts raised against the roving Indians. One solitary town, Tampa Town, was able to put in a claim in favor of its situation. In Texas, on the contrary, the towns are much more numerous and important. Corpus Christi in the county of Nueces, and all the cities situated on the Rio Bravo, Laredo, Carmelites, San Ignacio, the Webb, Rio Grande City of the Star, Edinburgh and Hidalgo, Santa Rita, El Panda, Brownsville, and the Cameron formed an imposing league against the pretensions of Florida. So, scarcely was the decision known when Texas and Floridan deputies arrived at Baltimore in an incredibly short space of time. From that very moment, President Barbicane and the influential members of the Gun Club were besieged day and night by formidable claims. If certain cities of Greece contended for the honor of having given birth to Homer, here were two entire states threatening to come to blows about the question of a cannon. The rival parties promenaded the streets with arms in their hands, and at every occasion of their meeting a collision was to be apprehended which might have been attended with disastrous results. Happily, the prudence and address of President Barbicane averted the danger. These personal demonstrations found a division in the newspapers of different states. The New York Herald and the Tribune supported Texas, while the Times and the American Review espoused the cause of Floridan deputies. The members of the Gun Club could not decide to which to give the preference. Texas produced its array of 26 counties. Florida replied that 12 counties were better than 26 in a country only 1/6 part of the size. Texas plumed itself upon its 330,000 natives. Florida, with a far smaller territory, boasts of being much more densely populated with 56,000. The Texas, though the columns of the Herald claimed that some regard should be had to a state which grew the best cotton in all America, produced the best green oak for service of the Navy, and contained the finest oil, besides iron mines, in which the yield was 50% of pure metal. To this, the American Review replied that the soil of Florida, although not equally rich, afforded the best conditions for the molding and casting of the Columbiad, consisting as it did of sand and argillaceous earth. That may be all very well, replied the Texans, but you must first get to this country. Now, with the communications with Florida are difficult, while the coast of Texas offers the Bay of Galveston, which produces a circumference of 14 leagues and is capable of containing the navies of the entire world. A pretty notion truly, replied the papers of interest of Florida, that of Galveston Bay below the 29th parallel. Have we not got the Bay of Espiritu Santo, opening precisely upon the 28th degree, and by which ships can reach Tampa Town by direct route? A fine bay, half choked with sand. Choke yourselves, returned the others. Thus the war went on for several days, when Florida endeavored to draw her adversary away from the fresh ground, and one morning the Times hinted that, the enterprise being essentially American, it ought not to be attempted upon other than purely American territory. To these words Texas retorted, America, are we not so much as you? Were not Texas and Florida both incorporated into the Union in 1845? Undoubtedly, replied the Times, but we have belonged to the Americans ever since 1820. Yes, returned the Tribune, after having been Spaniards or English for 200 years, you were sold to the United States for $5 million. Well, and why we need blush for that? Was not Louisiana bought from Napoleon in 1803 at the price of $16 million? Scandalous, roared the Texas deputies. A wretched little strip of country like Florida to dare to compare itself to Texas, who in place of selling herself asserted her own independence, drove out the Mexicans on March 2nd, 1846, and declared herself a federal republic after a victory gained by Samuel Houston on the banks of San Jacinto over the troops of Santa Anna, a country, in fine, which voluntarily annexed itself to the United States of America. Yes, it was afraid of the Mexicans, replied Florida. Afraid? From this moment the state of things became intolerable. A sanguinary encounter seemed daily imminent between the two parties of the streets of Baltimore. It became necessary to keep an eye upon the deputies. President Barbicane knew not which way to look. Notes, documents, letters full of menaces showered down upon his house. Which side ought he to take? As regarded the appropriation of soil, the facility of communication, the rapidity of transport, the claims of both states were evenly balanced. As for political prepossessions, they had nothing to do with the question. This deadlock had existed for some little time, when Barbicane resolved to get rid of it all at once. He called a meeting of his colleagues, and laid before them a proposition which, it will be seen, was profoundly sagacious. On carefully considering, he said, what is going on now between Florida and Texas, it is clear that the same difficulties will recur with all the towns of the favored state. The rivalry will descend from state to city, and so on downward. Now Texas possesses 11 towns within the prescribed conditions, which will further dispute the honor and create us new enemies, while Florida has only one. I go in, therefore, for Florida and Tampa Town. This decision, on being made known, utterly crushed the Texan deputies. Seized with an indescribable fury, they addressed the threatening letters to different members of the gun club by name. The magistrates had but one course to take, and they took it. They chartered a special train, forced the Texans into whether they would or not, and then quitted the city with a speed of 30 miles an hour. Quickly, however, as they were dispatched, they found time to hurl one last and bitter sarcasm at their adversaries. Alluding to the extent of Florida, a mere peninsula confined between two seas, they pretended that it would never sustain the shock of the discharge, and that it would bust up at the very first shot. Very well, let it bust up, replied the Floridans, with a brevity of the days of ancient Sparta. End of chapter 11. Recorded in Austin, Texas.
Okay, so that is the end for today. I finished my postcard, which I'm pretty happy about. I didn't think I was going to finish it today, but it's done. Go me. And I will be moving on to this one, which is a bunch of bugs next time. And we will also be continuing on with From the Earth to the Moon. I did forget to mention, but I did know this going into the audiobook, that it does have like 4 or 5 different narrators that just take over chapters as the book goes on. So yeah, maybe not. In terms of narrator, I don't think this has been the best choice of book. I think I'll have to pay a little bit more attention to the narrators next time I select the audiobook or am looking at it. I'll probably go for more of the ones that are like the dramatic presentations, like what we had for Frankenstein, because I think those tend to be pretty well produced and put together. But anyway, you can let me know what you've been working on and also what you've been thinking of From the Earth to the Moon. I kind of like it so far, but it's not... I don't know, I feel like Jules Verne's books usually, like, people are going places and, you know, they're about exciting journeys. And so far, people aren't going any place. They're just trying to shoot a big cannon at the moon, which is also kind of entertaining. But not quite exactly what I was expecting. So, yep, that's all for today. Let me know how your crafting went today, and I will talk to you guys on Wednesday when there will be another episode at the normal time of 7 p.m. Pacific time. So I will see you guys then. Good night.